In this episode, we talk about how to investigate a wetland outlet pit and check if it's draining the way it should be. Hey everyone, and welcome back to Ideanthro. In today's video, we are going to be talking about how you investigate water level issues within a constructed stormwater treatment wetland. So Ben and I have spent the morning out at this particular wetland here. We've opened up a few pits and we were investigating some water level stuff here, and I want to talk you through that. I'll give you a brief bit of context about why we were out here today, but it's not really the point of this. So at Stormwater 2016 conference, which was about a week or so ago from when we're recording this, might be a little bit longer ago by the time this video comes out. At Stormwater 2016, on the tech tour, one of the sites was Gainsborough Greens. Sean Linster from Design Flow presented on it, told us lots of really interesting stuff. He made a comment about some stormwater treatment wetlands, when they start to have issues with the vegetation dying off and the birds moving in and then turning to open water. He mentioned the possibility of temporarily draining down wetlands to give the veg a chance to re-establish. Ben and I were out at this particular wetland, which we won't identify, looking at the outlet structure to see whether draining it would be possible. We don't have permission to drain it, we have not drained it, we haven't done anything like that, but we were looking to see if it was possible to do so. But in the process, we found a few interesting little dynamics with this wetland, and I wanted to explain our process of how we investigated it. So let's orient you to the site first. So, Ben, if you spin around a little without falling into the pit, you can see coming into shot there, the wetland itself. Obviously it doesn't look particularly stormwater treatment wetlandy because there's not a lot of emergent vegetation left in it yet. It once did have heaps and heaps of vegetation in it. Comes around, coming kind of panning down there, there would be, that's the deep pool in shot there. There's a pipe from the deep pool that runs down to the pit that is right below us here. Ben's going to need to step back to get that into shot. This outlet pit here, and then there's another pipe running from this part of the pit straight out there and down into the natural wetland downstream. And so we came to investigate this. And so what I suppose I want to explain to you is, if you have a wetland where you think perhaps the water level is too high, what would be my approach to investigating what might be going on with that? So the first thing, I would work from upstream to downstream here. So in the case of this particular wetland, and you're probably going to need to get in closer, Ben, in the case of this particular wetland, it uses a weir plate to control water level. So what is meant to happen here, you can hopefully see that there is this plate across the pit. That plate extends, you can see the top of it in shot there, it extends all the way down to the base of the pit. It is sealed in on the sides and on the base, so it holds water back. But obviously there's a few holes drained in this because you can see water pouring through. There are 2 rows of holes, here and here, and there are 4 holes in each. You can see the hole where the water's coming out. There is 1 hole below that on each side and 2 holes above it, for a total of 4 holes on each side. So ideally what's happening with a wetland like this is that if it hasn't rained for a while, the bottom of the lowest hole there sets the water level back up through the wetland. Because you imagine if it did rain, water flows into the wetland, raises up in the wetland, raises up in this pit. In fact, it rained yesterday. You can probably see the mark on the side of the pit there where you've got the light color at the top and it goes down to the dark color lower down, and then you get to the water below that. So you can see how high the water level was even yesterday, I think, in this particular wetland, because it rained really heavily for a short period of time. So the water level is normally set in the wetland by the invert, the bottom of the lowest hole there. And so then when it rains, the water level fills up and then it drains back down slowly over the course of a day or two through those particular holes. So the first thing, if I was coming out to a wetland to check water level issues, would be that, assuming it's been designed well, then the base of that hole should be setting the correct water level back up in the wetland. So I'd be looking at any of these holes. In this case it's a weir plate, but it could be a riser arrangement. I'll show a picture on the screen just now of a riser arrangement. So you can see there's a PVC pipe, a vertical PVC pipe where water can flow out of that. So similarly, it's got holes in it. So the holes are performing the same role, only this here is a plate. That picture that I just had up there is a circular piece of PVC pipe. Anyway, so the first thing that I would look at if I think the water level's too high in the wetland and maybe causing problems for the plants was I'd look at all the holes on the riser plate and see if they were blocked in any way, shape or form, which these were to some degree, not totally, but earlier we pulled this stuff. That's, is that actually a bag? Or is that, what is it? It's a plastic bag. So we pulled these plastic bags out of it earlier and unblocked them a little. That could be one problem. The next thing to then think about is what's happening with the water on the downstream level of the pit here. Because in this instance, what we've noticed, like ideally, what you'll have is that this side of the pit, which is the downstream end, will be quite free draining. So that once the water gets through the weir plate there, it gets away easily on this side. And in an ideal world, there might even be some sort of sluice valve that you can open to completely drain the wetland out. In this case though, you probably can't see it on the video, but we mentioned the four holes on each side. The bottom hole is actually submerged on this side here. So this says to me, the designer of this wetland intended that when it hadn't rained for a while, this wetland would drain back down to a water level equal to the base of the lowest of those four holes. But that's never going to happen here because the water level on this side of the pit, which is controlled by the water level in the natural environment behind us, is too high. So already artificially, this wetland's water level is probably jacked up 5 centimeters or so, which isn't massive, but it's a little bit higher than it ideally should be. So this is the process of investigating this. So I'm looking at the wetland itself. I'm looking at the water coming in. I'm looking for the various holes in the riser arrangement. Are they freely draining? If they are, okay, can they drain back down? Okay, what's happening on this downstream side of the pit? Is that water level low enough that those holes can drain through, or have we got a backwater effect happening? And we've got a bit of a backwater effect happening with this wetland. Then the question becomes, why is the water backwatering on this side? There could be 2 reasons for that. The first one could be that there could be a blockage in this pipe somewhere, or a partial blockage. That's possible. It's like a 300 mil diameter pipe though. It's a fairly serious pipe. That seems unlikely for there to be a blockage here, particularly with the riser plate in the way, unless there's a blockage right at the downstream end. Or more likely than that, it's literally just the water. In this case, we can see the wetland right just through there. We kind of eyeballed this initially and we're like, oh, we think the water level down in the pit here is the same as that water level there. We then got out the survey staff and the laser level, and we checked it. And indeed, the water level in the pit here and the water level in the downstream environment are very, very similar. We couldn't get a lot of accuracy on it, but we're confident that they're the same. So we were like, okay, we've got a bit of a backwater issue from that downstream environment, and then that can start to inform what we think about, is the water level appropriate back up in the wetland? And that's essentially how we go and investigate a pit. A few final thoughts. I can't help but mention this. If you do decide to come out and look at wetland outlet pits, be safe about it. There is some risk inherent in this. Clearly, I am sitting on the edge of this pit. That is probably not a sensible thing to do. Equally, these lids are really, really heavy on outlet pits. So you should take the necessary precautions when, if you decide to open those, to do that in a manner that you deem to be safe. Equally, taking care, standing around them, all the same. So I just want to make sure that you're, aware that this is, there's a bit of effort that goes into being able to investigate this sort of thing, and you should come prepared, think it through, and then if you're not comfortable with what you're doing, figure out what you need to do to make it safe, make it comfortable, and then progress from there. Okay, safety stuff over. That's it. I hope this was useful looking at wetland outlet pits. But until next time, see ya, have a good one, and we'll see you soon.